Hey everyone, welcome to the project series, and in which we'll be doing all the project and seeing and applying the algorithm into code, and let's see what it does. Okay, so let's get started. So first of all, I'm using Kaggle for the dataset, and the dataset I'm using is the Miami housing dataset. It was a good dataset. I thought, yeah, let's do it. And the problem I'm mainly working in is linear regression. I thought, let's make a project on linear regression from end to end, then explain to you all guys also that how do we do it and how do you actually code, and let's learn from my mistake and from yours also. So yeah, that's was the thing. And I want to tell you that, yeah, I'm just using the Jupyter notebook of Kaggle. Okay, then I'll be using the file formats, okay, as you can see. And what I want to tell you actually, that from past 3 or 4 days I'm trying to make this lecture, but still I not able to make it because there were some reasons, like I recorded, then the recording went corrupted, or the audio got up and down. Okay, I think this would be the this time that I'm doing right now. Okay, yeah, after many trials, this is the 5th time I'm recording this lecture. Okay, yeah, so this is my data set that I'm using. Okay, and this is that I have done some of work already. So let's get started, and let's first of all talk about the structure that I will follow. Okay, so the structure that I will follow is that first I'll be using Kaggle for the Jupyter, Kaggle for the Jupyter notebook. Okay, then I'll be moving to the file formats. Okay, I'll be doing that. Okay, I will just use Kaggle for the Jupyter notebook. Then I will install the Jupyter notebook. Okay, no, sorry, download it. I will download this file, and then I will use it in my this VS Code project, in which I'll be doing from end to end. Okay, using the deployment also. And what I'll be using is, see, I would have a separate folder for the all of things like the data ingest. Okay, for the data ingest, then I would say pre-processing. Okay, as it actually done in the industry, we'll deal with this. Then pipelines, then then we'll have our model, then I will we'll have our run file. Okay, then we'll have our evaluation files. Okay, all this file we'll be dealing with this, okay, after this project. Okay, and let's get started. And I have actually done some of work in the my VS Code also, so I thought let's use Kaggle for it. But yeah, so for in the Kaggle, what I'll be doing this in the Kaggle itself, what I'll be doing is that I will do from end to end. Okay, as you do in the Kaggle. Okay, what you do is like from the data ingest. Okay, as you do from the data ingest to model training and all those things that we are going to do. So first of all, what we'll be doing, that we'll be doing in the Jupyter notebook itself. Then we'll be moving to this. Okay, the VS Code. Got it? So that is the thing that I've done. Okay, so that was my structure for this. Okay, I'll be doing everything in it. Then once I'm complete doing everything from it, okay, I'm complete with after completing everything doing in the notebook, then I'll move into the file formats. Then I'll use the deployments and all those things that is needed. Okay, yeah. So yep, that is the project. So let me give with the all the context about the thing that I have done. So first I imported all the important libraries as we do. Then I ingested the data. There is the data that I have in the folder here. Okay, so let me make it hide. Then moving ahead, I did some I did some data exploration. Okay, as we do before jumping into the project and doing all those things. Okay, then no, I don't necessarily. Then I used and I exported the data. The shape of the data is around 14,000. is good, like the optimum. Then I described the data. I've got the count, mean, median, and all those things that we do. Then the procedure that we do from the generations. Then I got the info, and the best part of this data set, that it does not have any kind of object. Okay, it does not have any kind of object, which is a new experience, cause having objects and not having objects variabilities are like two cases. Like if you have objects and if you don't have the objects, then okay, so if you have the objects, okay, and if you don't know objects, okay, then there's a different case, because if you have the object, then you need to use the feature engineering, okay, feature engineering, and then converting the into numerical and as the data demand is. And in the if you have the no object, then it is a very clean that you don't need that much of data processing and preparing the data for before training to the model. Okay, now moving to ahead, we have another thing that I have done, the outliers checking. And outliers is one of the most important thing or the crucial thing that we need to do before checking the data, because we cannot have some of the data points which are biased. Okay, we can have some data set which are biased, and that will affect our prediction. Okay, and the main thing that I'm not, my thing is to getting as much as high accuracy of that, how well our model can predict. Okay, just around 0.9 or something. No, this is not my aim. My aim actually is to build a very good project that actually what I would say, that is actually robust and that can be used. Okay, that is very good for this. That can be used for long time in the robust thing, as like not only the accuracy part. I don't need the accuracy that it should be 0.9 or 0.95. No, I don't need that maximizing the accuracy as much as possible. No, that's not my agenda, you could say. Then moving to ahead, then I dealt with the missing values, and surprisingly it doesn't have any kind of missing value. You could see that it does not have any kind of null value, so that was pretty good. Then moving ahead, then I checked the outliers using the Plotly. Okay, generally telling you, I don't know how to use Plotly. I just copy pastes from my another project. Okay, yeah, that's the reality. And you can see there are some outliers, and what we have to actually predict is that we have to predict the sale price of that house that is in the Miami. Okay, then these were the outliers. Now I built then I wrote a function that actually removed the outliers. So what I did actually, that I have actually done here also, that all the things that I have actually even done here also. So after checking the outliers, what I did here is, yeah, here we have our outliers. So let's use this function. Okay, so this was my old. Okay, now this is my new. Okay, that I have actually coded it. Okay, so it's not a copy paste also from somewhere else. It's mine handwritten. Okay, or from the fingers. So this is the for removing the outliers. Now let's run this cell. Now let me do some 1 million cells another. Okay, now moving ahead, we have this is a very important thing that I have actually done it for saving the time, that actually just telling you and explaining you thing that I've done. Okay, so what I've done actually here is that I made a function remove outliers. It is taking two parameters, a data frame and the columns. Okay, all the columns that contain the outliers. Okay, now I'm copying the data frame, okay, this into a new data frame called DA filter, in which we'll have all the outliers that are filtered. Okay, then what I'm doing, that I am running a for loop in the columns. Okay, all the columns that contain outliers, then I'm storing its percentile, 0.5, 25 percentile and 75th percentile. Okay, and then I'm getting the interquartile range IQR, which is nothing but the subtracting the percentile, the 25th percentile from the 75th percentile, and I'll be getting the IQR. Then after getting the IQR, our main aim. Okay, let me show you here. So this is our 75th percentile of this data, and this is 25th, and beyond this, okay, see, let me tell you. So this is our 75th, okay, and this is our 25th. Okay, and beyond this point, if there is any data set, then there is no use of that. Okay, there is actually no use of that, because that data can be biased. Okay, suppose what we have is that You just need to understand that we have 5, 7, okay, 8, 11. Okay, suppose that these are the number of chocolates kids have. Okay, so there is a kid 1, kid 2, and there is another kid, okay, who has around 200 candies or chocolates. So you could say that this was the graph. If I plot in the graph, then it was like this, this, and it was suddenly like this. Okay, so you could see that here we have a tremendous, rise in the value. And if we take this value, then this can be biased also. Suppose that if we take the mean of it, okay, if we take the mean of it, then what it is, 5 plus 7 plus 8 plus 11, okay, plus 200, okay, and what will the mean of it? So 7, 5, 35, 12, 8, 20, and 31. So 231, the sum of it, it will be 231. Okay, we have 5 values, so let's quickly do a quick math. So 231 divided by how much? 5. Okay, so 46.2, which means the mean of it, the mean of above values is what was it, man? Yeah, 46.2. So this means that around every kid, this, each have 46 candies, which is not the case here. Okay, which is not the case here actually, because this have only 5, and this is very far from the mean actually. If you see, then what if it would be around 40, yeah, it is a reasonable. If it is around 35, 42, it is reasonable. But man, you could see that there is a tremendous distance from the mean. That is not a good thing, and that's why this is biased, and we need to remove this kid, or the chocolate does it have that won't affect us. Okay, so suppose from the example there are like group of 5 people, as most of says. So in which 4 people are poor and one is like rich, like filthy rich. One I would just filthy rich, like he has around, I would say, 900 million. Okay, it's not 4, but still it's a lot of money. Okay, and one man with a net worth of 900 million. Okay, 900 million. Okay, don't you think he is an exception in this group? He is an exception. Like we have 4 people, suppose you, me, and other 4s, and suppose I have 900 million. Yeah, man, why cannot? Yeah, okay, I have 900 million. Then don't you think that I'm a exception on a group, the richest and the filthy rich? So that's the thing. So you need to remove me, and you won't remove me, I will leave you. No, that's not the case, but still, yeah, we'll do it. So yeah, this is the thing, that we need to remove this person, or me. Okay, you need to remove me. And who is me? Rishabh. Okay, you need to remove me from the group, that you could be at same level. Okay, so that was the thing that we do in the outlier, that it can give us the bias result. That's why we'll do it. So then I did the upper limit. Upper limit is that beyond, this is the upper limit, that if any value lies beyond this upper limit, then it will be removed. Okay, and lower limit below this, then it will be removed. Then I stored in this data frame, then I returned the data frame, then I stored in the variable new data frame without outliers. Then I call the function, okay, pass the parameters, data frame, and all the columns that contain the column with the outliers. Okay, sometimes I get stuck also. Okay, so now let's call our data frame. Okay, wait, is this yeah, so we'll need to run from starting. Okay, so it is running, man. Let's see, data frame. Okay, let's chill. It's still running. Wait, what happened, man? Sorry for these kind of noises. Man, still, let's run it, man. Come on, it's taking a lot of time. Should we do it again? Yeah, yes, next. 0, yes, we don't have a null value. Yes, we don't have actually. What is happening, man? What is happening? Yes, we got our all the values now. Now this. Okay, so we have got our data frame without outlier. Okay, so let's print this. Yeah, now we have reduced. Okay, so we have less rows compared to the previous one because we have around 900, sorry, 13,932. Yeah, that's my good memory. Yeah, so we have got 10,321. That is less from the beyond, from the earlier one. That is a very good thing. Now moving ahead, we have got the sheep, we have all the thing. Now the most important thing is that I know that I will be I will use the wait, I will use the linear regression model. Okay, I will use the I will use linear regression in this data set. But does this data set, okay, does does this data set, we should apply linear regression to it, or the linear regression algorithm, does it have all the, what I would say, that the condition that is satisfied, that we need to apply linear regression to it, and that's where assumptions comes. Okay, so if we don't have assumptions, what is assumption? Just pre-assumed conditions from the data set, that we ask that if the data set, suppose that we have this data set. Okay, and if this data set takes all our, like, suppose we have expectation from this. Suppose you go to the school, and in the school you don't have benches or desks or any kind of boards, then school, it should have boards, benches, chalks, markers, and all those things. That is should be in a school. Okay, and if you don't have those things in the school, then it is not a school. It can be a home, it can be a room, whatever. It can be many things. So if the data set passes these assumptions or our conditions, okay, our conditions, then we can say that, yeah, this is a thing where we can apply this thing. Okay, suppose that you go to a school. Okay, suppose that you go on a path. Okay, so this is a road. Okay, this is a road, and you have a house here. Okay, you have a one building here, and you have a one building here. Okay, now you are here. Suppose that it's you. Okay, it's you with some muscles. Okay, wait, bad. Why should I do it? But yeah, suppose that it's not you, man. Suppose just suppose it's you. Okay, just suppose it's you. Okay, now you have to go there. You have to go here also, and you have to go here also. Okay, now you came around here. Okay, you came around here, and you met me. Okay, you met me, and I told you that according to you, okay, according to you, this is your left. Wait, according to your perspective, this is your left, and this is your right. Suppose that you're walking from this side. Okay, this side, you're walking from this side, so this will be left, and this will be your right. Not K, man, it's right. Okay, now I have told you that if you go to the left side, you'll get school. Okay, it's me saying. And if you go to the right side, you will get hospital. Now you go to the left side, and you go and visit the building, and in the building you find scissors, bandages, and all the medication things, and they're a patient. Then you will be like, man, Rishabh told me that it here we will find a school, but it is not a school, it is a hospital. Okay, so the condition that has the condition, what is the condition for having a school? Markers, benches, teachers, offices, classrooms, and all those things. So you got here no. So is this a school? No. When you go to the right side, you find all the criteria, that is all the conditions satisfying. Then it is a school? Yes. Is it a school? Yes. And that is the thing that we want. Here is a school. So like that, we ask here also that is this data set have all the condition to apply that particular algorithm, which is linear regression. Okay, which is linear regression. Okay, and for linear regression, we have some assumptions. Okay, we have some assumptions for linear regression. Okay, so what are the assumptions for linear regression? The first assumption we have is linearity assumption. Okay, and I'll be telling you about this. The second one is independence. Then the third one is what was that? Homoscedasticity. Okay, and the fourth one is normality assumption, and the fifth one is no multicollinearity. Okay, no multicollinearity, and these are the assumption. Okay, so these are the assumption. There is another assumption, that is autocorrelation assumption, but we won't be using it. So yeah, these are the assumption that if these assumptions are satisfied by this data set, then we will use the linear regression or any linear model. Okay, linear algorithm. Okay, so for that I have did the assumptions here. Okay, you could see I have done the linearity assumption and the dependence assumption and the homoscedasticity assumptions. Okay, so let's understand what these assumptions is. So first assumption we have is linearity. Okay, linearity, and the second one we have is independence. Okay, so let's understand it very quick. Okay, so if what this linearity says is that the relationship between x and the y, okay, the relationship between the feature and the label is linear or not. Okay, so what did I say? Got it. Suppose, yeah, this is my, where is the text here? So this is the x, okay, and this is the y. So suppose if this is 1, this is 2. If this is 2, okay, this is 3. Okay, if this is 3, it is 4. If it is 4, it is 5. So what did you see? What did you see here? So we saw that if it's 1, it's 1 plus 1. Y is y equal to x plus 1. So whatever the value of x we given, it will result into just one more. Okay, it will result into just one more. Okay, so that is the thing that we are dealing here. Okay, so is the data linear between the, is the relationship between this is linear? If this is increasing, this also increasing. If this is increasing, x increasing, y is also increasing. If x is increasing, yeah, so is this linear? Yes. So that is this assumption chase. Okay, the linearity assumption assume from the data set that the relationship between the feature and the label is linear or not. If it is linear, then we will use a linear regression, and if it is not, and if it is not, then we won't. Okay, the second is assumption and independence. Sorry, so in the independence says that is the errors. Okay, oh my god, yeah, errors. Okay, the errors are independent of each other or not. Okay, so if we got, suppose that, what is the leave it. Okay, what is the difference? Suppose that in wait, let me give you the graph. So it's like this. Okay, we would have our prediction line here like this. Okay, and we would have some of the data set like this. Okay, so this is our data points. Okay, and now the distance between the predicted and the actual value, is we call as error. So if this error is influencing this error, then it is not independent. Okay, if it need to be independent, then this should not affect this, and if this is affecting it or influencing it, then this is not satisfying our assumption. Okay, we need to check this data set. Okay, so these were the two assumptions that we need to check right now, because homoscedasticity, normality and no multicollinearity we'll be doing it, but that is the first thing that we need to do it. And right now I have done this also, so let me copy all this thing. Okay, import, this is our, let's run it, man. Then homoscedasticity, no, not this, homoscedasticity was here, but still we haven't done it, homoscedasticity actually. For the linearity, I plotted the, here we have code, then we'll do this. Is it running? Yeah. So we have got our graph that which shows that the relationship between x and y is linear. If the relationship between the x and the y is linear, then it will show us the linear graph like this, but it is not actually. See. The graph between latitude and sale price is not linear that much. The longitude between sale price, it's not that linear. The parcel number and not that linear. The total living area is kind of a linear. See, this is kind of linear making it. Then we could say that this is not linear. Ocean and water distance, center distance, sub-center distance, and all this thing. You could say this is kind of a linear, but it is not that linear. You know, that is the thing. Then I got out the Watson test that. So this data set is, and all the assumption testing, this telling is that linear regression not appropriate algorithm for this. Okay, so what we need to do is that we need to use some different algorithm, but for right now we not using it, we're just experimenting it. Okay, so what I'm doing here is right now is that I have got our data. Okay, I've got our data. Now what I will do is that I will perform the next thing, splitting our data, building the models, all this thing that I have done earlier. Okay, so give you the prediction. Okay, so let's do it. So we have our data, we don't need to apply algorithm, so but we'll do it, man. We have to do experiment and we have to check that it is not. Okay, so what we'll be doing this, that we'll be splitting the data. Let me code here. Okay, yeah, we'll be splitting the data. Then second would be training the model, then evaluation. Okay, then after evaluation, okay, what we'll do next, let's keep it till here, till evaluation, and after the evaluation we'll check that what we have to do. Okay, for getting the better data set. Okay, so as what I had in my mind is that we need to split the data set into three sets. Okay, as if you don't know, then we had to split in the, okay, train, valid and test data set. So these data set are used for, you know, actual in the industry level, because two data set are not actually good for the model, because you are taking from the data that is kind of a seen data. So test data set is the data set that is unseen. Okay, so without any talks, let's get started with it. So we will define our x variable. So we are actually splitting the data. So splitting the data. Now our x variable, it will have new df without outliers, drop. What it will drop? It will drop the sale price, because sale, yeah, it is in capital sale price in the axis 1 because it's column, and in the y new df we will give it the sale price, not here, man. Yep. So we have defined our variable. Oh, sorry. Yeah, right. Nice. Yeah. So we have got our this data set. Okay. Now we'll split the data set. We have actually split the data set here. Okay. Now we don't have to deal with any kind of feature engineering and all those things, because this data set is not using any kind of thing. But if we need it, then we'll definitely do it. Okay. We'll definitely do it, because we're just using and doing this for the temporary purpose. Okay. So x train, x test, y train, y test. Okay. So we'll use this. Wait, have I imported it or not? No, I have not imported it. So let's import it first. So for importing it, from sklearn dot model selection, import, not import train test split. Okay. So train test split will split x and y, and the test size will be 0.2 or 0.3. I think we should keep it 0.3. Then the random state will be 0. Okay. So this is we have splitted our data set. Now we'll perform as you all do, noobs. You all are noobs if you do like this. Okay. So first, what we'll do, that we'll go and we'll import our the model, which is from sklearn dot linear model. Okay, so the data set is linear, so we need to import the linear. From linear model, import linear regression. Yeah, the beautiful model, the linear regression. Then the linear regression, we have created an instance. Then the model dot fit, we will fit x train and y train. Then sure. Okay, so we have actually did this. Now the next thing is to prediction. Okay, so we'll do the y prediction. Okay, for the y prediction, then we'll predict it using the model. So model dot predict on our test data set. This is our test data set. We have got it. Yeah. Now we have till here. Now let's get the score of it. Okay, so model dot score y test versus y pred. Okay, let's run it. So we're getting an error. So here will be y pred and y test. My mistake. Again, my mistake. It's not reshape or either using. Let's y pred. Then let's see what y pred is. It is an array. Okay. So have I got this same error in my previous thing that I was doing actually? No, I have. Oh, sorry. I had to actually use in a prediction, and I had to score. Score using this. So I'm not just be copy pasting all those things. So I have actually used in it doesn't actually need that much prediction. I have stored it in ypred. Then I printed ypred. Then model score. Pretty weird. Okay. So what this says that regression mix in their score. Let me write this thing. No man, not this. This is it from the X test. Wait, I'm doing something wrong, man. Score, wait, yeah, man, my score would be from the X test and the Y pred. I think. Yeah, that's the thing I missed actually. It should be X test because we're actually checking from the X test that is it right or wrong. Okay, is it right or wrong? Then moving ahead, what we have right now to do? Yeah, so let's do and plot our scatter plot. Okay, so before that, so as the data set is same like this, so I'm just copy pasting on all those things. Okay, wait, it's not prediction, man, it's widespread. So yeah, this is the graph between the y test and the widespread. Okay, y test and the prediction. Now what is the actual data points that we have? So now we need actually a line that is prediction. Okay, so we need actually not a line, or I would say plt.plot. It should be a line. Okay, so let's ask GPT man why it is for then. See, I don't, I have actually forgot how to do it. So why should not I ask the GPT? Okay, so how to plot the scatter plot in linear regression. Okay, we don't need this, but still, you know what I'm forgetting actually is not these, but a parameter that is actually I don't need this, don't need this widespread. Yes, plot. Actually, what I was trying to do is plot. Okay. Okay. So it should be a line actually. See, let's copy paste from here. Not there, man. Here, and let me comment this. Use this. It is not actually X, so it will be X test, Y test. This X test. We get error. Yes. We have got error. No, we don't have any problem. X and Y must be same. Okay. So yeah, in the plot we actually want a line. Okay, so if we want to plot a line, this is a basic thing, man, but why the hell I'm forgetting, but still what we want actually is that a line. Okay, so this is the line of the prediction. Okay, and these data set points are the data points. Okay, so now between the widespread and xx, so this actually the line for the prediction. Okay, so we have actually gave this widespread here. Okay, so yeah, so yeah guys, so I think I need to wrap this up. This has been very long, and I actually spent this whole time in explaining you things, and this is the thing I will sort out. Okay, and I will make you explain also that what I had to do, and it's been so long for this lecture. So thank you for watching till right now, and if you have any doubt you could ask me in the Discord, or you can pin me out in the comment that you have this doubt and if you haven't got this. So yeah, thanks for watching till right now. Have a nice day and join the Discord. Okay.